Good morning, good afternoon, good evening, everyone. I'm Kezhi from Singapore, Nanyang Technological University. I will present a recent research on the large language model-based text classification. Okay, so these are the main contents of my talk. So firstly, I will briefly introduce the in-context learning and its performance factors. And then I will present two pieces of research work. One is on the demonstration example selection based on the logic separability maximization. And then actually the second piece is on the selection and the use of multiple words for demonstration example labeling. So finally, I will present some experiment results and analysis. Okay. In conventional machine learning, normally, we start from the collection of training data and also the labeling of that training data. And then, based on the training data, we train a model for this specific task. And to get a good performance of a model, and normally a sizable training data is needed. But we know actually sometimes the collection and labeling of training data is quite challenging. And if we have a new task, and then we need to repeat the process. Okay. So in-context learning is a new machine learning paradigm based on the large language model. And a model learns to perform a task by observing examples. So on this slide, I show one example on the in-context learning for text classification. Actually, this is a sentiment classification problem. Okay, so you can see actually first actually we provide some examples like review and also give the corresponding class label positive, and then give one example negative class like review and then sentiment negative. Okay, together with a query. Okay, we want to and then we input these examples and the query to the large language model. The large language model will provide the predict label for the query review. So this is the flow chart for the in-context learning. So from this diagram, you can see there is no need to collect a large number of training data to train a model. So instead, we just need to provide a couple of examples. Okay, then the large model could adapt to our task and give the prediction of the class labels. And the performance of the in-context learning is affected mainly by two factors. One, of course, is the large language model. And for the large language model, the model architecture and the size actually indeed actually affect the performance. And basically, the larger the model, the better the performance. The performance of a large language model also is actually partly determined by the training data. And not only the quality, but also the quantity and also the mean diversity affect actually the performance of the large language model. Another is the training process. So the learning algorithms and also the setting of the hyperparameters. Okay, so this is the performance factor one, the large language model. And then, of course, actually from the diagram, we can see another actually the demonstration examples. So these demonstration examples actually affect the performance very much. Okay, and of course, actually we should use actually the good quality of examples, and these examples should be representative and should be diverse. And of course, the information provided, the example provided to the large language model should be accurate. We should not provide ambiguous examples to confuse the large language model. And the order of the examples presented to the large language model also affect the performance. Okay. And also the number of examples. So normally, the more examples we provided to the large language model, the better the performance of in-context learning. But the number of examples is subject to the limit of content length and memory. Okay. And often overlooked issue is the labeling of the examples. So today later we will show actually the labeling of the examples is also very important. Okay, and then we propose and use the so-called actually a multi-word labeling of the training demonstration examples, and to improve the performance of in-context learning. Okay, so next actually talk about the selection of demonstration examples. In this work, actually, we try to actually select the examples that are representative. Okay. When an example is input to the large language model, it's just showing this diagram. Okay. And the large language model will provide the logic for each token in the vocabulary. And then, of course, actually, based on the softmax, actually, we can normalize the logic to probability. And then we can select those with large probability as the output of the large language model. So normally, if an example that is very positive, okay, and then actually, it should words positive, it should have large values on many words. Okay, so here actually we will use the logic of words in the label verbalizers only. So what is the label verbalizer? Verbalizer actually is a mapping from the label words to the specific class. And this diagram just shows the mapping of some words like enthusiastic, bravo, positive, great, actually to positive class label in the sentiment analysis task. And then negative, bad, and unwanted. So many actually words actually are mapped to negative class of the sentiment. Verbalizer actually brings a projection from the vocabulary to the label space. A study has shown the use of verbalizer could improve the performance of in-context learning. So let's look at the characteristics of the logics of good quality examples. As just mentioned, we should select representative examples. These examples should not ambiguous, should be unambiguous. Okay? If such an example is input to the large language model, then the logic on a set of positive words should have large values. While the logics of negative words for this input should have small values. Just as shown in this diagram, in the upper figure, we can see the horizontal axis denotes the index of the label words, and the vertical axis shows the logic values. Actually, from number 1 to around 220, all the words are negative words. Okay, so is blue right here denoted by blue, and then from 220 to around 600, 500, and then actually the words are all positive words, so actually denoted by the red color. Okay. From this diagram, you can see indeed actually for a very good example, representative, and the logic values on the positive words actually show larger values, and then the logic values of the negative words. Okay. So similarly, for negative examples, actually, the zero-shot learning logic of negative words in the verbalizer should have large values, and the logic of positive words should have small values. Of course, we should not judge whether it is good or bad based on just the logic of one single word. Instead, we should be based on the statistics. Okay, so next actually I will show actually how to evaluate the quality of the example based on the logic separability measure. Separability is a term used in the feature selection machine learning. And it refers to the degree that the objects in different groups can be distinguished from each other. Just as shown in this figure, and the logic values for negative words, actually all the values actually are located in one end of the axis, and the logic value for positive words all located in another end of the axis. So clearly, we can see the clear separation and between the values of the words in the two classes. Okay, so next actually we propose the so-called signal to noise ratio, directional directional signal-to-noise ratio and to evaluate the goodness or representativeness of an example. And so this actually a signal-to-noise ratio. It defines the ratio of the intergroup difference to intragroup variability. Okay. As shown in this equation, the numerator part actually is the difference between the two mean values. MP means actually the mean logic value for the positive words. MN means the mean logic value for the negative words. So we should actually have a larger value between the difference between the two mean values. Okay, and the denominators actually are the sigma p and sigma n are the standard deviations for the logic values of positive words and negative words. So the smaller the better. So here we use the ratio, and the larger the SNR value, the better the separability. Then we think this example is more representative. Another measure that we can use is a point biseral correlation. Point biseral correlation measures the strength and direction of the association between a continuous variable and a boundary variable. The continuous variable here means the logic values of words across all the words in the verbalizer, and the boundary value here variable means the class label, positive or negative. Okay, so basically, I think it also actually measures the ratio of the difference between the inter-class difference and also the within the class or intra-group variability. So sigma is the standard deviation. Okay. Okay, so now we have actually defined the measure to evaluate the goodness or representativeness of a demonstration example. Okay, so next actually I'll show the step-by-step procedure for the selection of the examples. So first, actually for all the training data, actually we input one by one to the larger model to obtain the logic values of all label words in the verbalizer. Okay. Then for each actually example, we evaluate the quality based on the logic separability measure, signal-to-noise ratio, or the point biseral correlation. And then we rank the positive and negative examples respectively. Okay. And if we want to perform the K-short learning, and then we select a top K positive examples and also the top K negative examples. Okay. This can be one, which is a one-shot learning, or can be any other number, positive number, if you want to perform few-shot learning. Okay. So after the example selection, the next step is to perform labeling. Okay. And quite often the examples are labeled just with the class label. Just as I showed in the start of the slides, actually, in the second analysis, give a review, then the label of this review is just the class label, positive sentiment or negative. Okay. And we find actually a single descriptive class label may not encapsulate all the semantic meanings within a label definition. Okay, and when we define something, quite often we besides the intentional definition, we use the so-called intentional definition, which define actually the words actually by listing all the individual instances falling under this term. For example, for the term sports, we can list the internal definition is something like our efforts, physical efforts, right? And by here, we list all the instances underlying below under this actually sports, like jogging, cycling, football. Okay, so essential definition of the class label could provide explicit and more comprehensive information of label semantics. Okay, so here actually, we use the logic separability measure to evaluate the goodness of the label words. Okay, and so here show the step-by-step procedure. Step one, we conduct actually the K-short learning. for all validation examples. Just now we see we have a training data set. Actually, we can subtract those actually have been selected as demonstration examples as validation examples. Okay, so we conduct short learning for the validation examples. This can be just one shot learning. As shown in this diagram, we give the review and give the sentiment, one positive example, one negative example, and also the label is just positive, negative. Okay, and then we give the each of the validation set. Okay, as a review, we input this to the larger model and then to obtain the logic values for each token in the vocabulary. Of course, actually, again, we'll just use the logic for these words in the word analysis. Okay. Then we enter the logic distribution of every word in the modelizer over all validation examples. And then again, we can calculate the separability using the signal-to-noise ratio or the point-by-serial correlation. In the words, in this actually label word selection and the example selection, we all use the logic separability measure, but we use this measure in different ways. In the example selection, we look at the distribution over all the words, okay, in the vocabulary as a measure for the goodness of example. Okay. So in the label word selection, we will evaluate the words, the goodness of a word by you measure the separability of the logics across all the validation examples. Okay, so then although we use the signal-to-noise ratio or the point-by-serial correlation, but we use it in different ways in the two tasks. So, and then we rank the positive words and negative words in the verbalizer and identify the best performing positive words and the negative words. For example, in linguistic for the positive class, hostile for the negative class. And then we expand the label, just like shown in this diagram. Now, for the sentiment, right, we beside the positive, the class label, we also include the NVIDIA state. For negative sentiment, besides negative, we also include the hostile. Okay, then we will repeat the whole process by input each of the validation examples to the larger model, and then we get the logics of all words in the verbalizer. So we will continue on this process until the stopping criterion is satisfied. And the stopping criterion could be actually the number of label words selected reach to the preset value. If you want to select 3, then you just after 3 label words are selected, then we can stop. Okay. And another stopping criterion is to see whether the performance improvement is significant after the addition of one extra label words. Okay, if the improvement is trivial or even we have the degradation of the performance, and then we should stop. Okay, so here actually I presented actually one the demonstration example selection, another is the label words selection and the use of the multiple words as for the labeling of the examples. So next actually I show the experiment result demonstration, and we use actually a few data set. Like the first 3 are for sentiment analysis task, and the next 2 are the emotion recognition task. And then we have the question answer classification, and also we have the agent news actually classification task. Okay. So totally we have actually 1, 2, 3, 4, 5, 6, 7 actually data set. Okay. And also we perform the testing based on different large language models, like GPT-2 and Llama 2, Llama 3. Okay. And in the left column, we show the different methods like random. Random means random select the demonstration example from the training set. And top K actually select actually the top can example that is similar to the test example. So there are different methods, right, in the literature. And we can just address and look at one result. For example, the second column, SST2 data set. Okay. And for the random method, and we will repeat the experiment 5 times, and then we take the average. Okay. And then we can see the performance accuracy is around 71.74. And with the same random selecting example, but we use multiple label words selected by our method, and we can see a very big improvement in the performance from 31% to 85%. A big improvement just because we have added one extra or the 3 extra words for the labeling of the examples. Okay, and actually, therefore, all other methods actually, now we use the other methods to select demonstration examples, and then we add our multi-label words. We can see the big improvement. For example, for top K, originally 69, then improved to 84. Okay, and the last part actually shows our result. Actually, ours actually demonstration example selection is based on the logic separability measure. The label word selection also based on our work. Actually, we can see actually the performance actually could be 91%. Okay, so it's a big improvement. And for all other data sets, we can observe actually the improvement, and the improvement is significant for this GPT-2 actually model. And for another larger model, Llama 2, 7 billion parameter, and we conduct the experiment, and actually we can also observe, of course, actually, even we use a random, the performance improve a lot, 93.6, right? Even we use random selected example. And it also shows actually one of the important actually performance factor, that is large language model, right? Llama 2, 7B outperform the GPT-2X. Okay. And so we can also see the performance improvement by carefully selecting the demonstration examples and the use and the selection of multiple words for the labeling of training examples. And for Llama 3, which is released recently, and we have done repeat experiment, and we can also see the improvement. For SS22 example for the data set, okay, the random 94%, and then if our methods in the last row, 96.84. So there is also a 2% improvement. Okay. Okay, so in my presentation, I presented two recent work, one on the selection of the demonstration examples based on the maximization of the separability of the logics. And another is the selection and also the use of multiple words for the example labeling. Okay. Actually, both methods are based on the separability measure of the logic, but we use this in different ways. Okay, and so in our study, actually, we have focused on our work in the text classification task. Okay, so whether this kind of idea can be extended to other applications is under exploration. Okay, so I think that's all for my talk. Yeah, thank you very much.